In this section, we'll be talking about inscribed angles and tangents. So first for inscribed angles, we have a few theorems that we're going to go through. First, if an angle is inscribed in a circle, then the measure of the angle equals 1/2 of the measure of its intercepted arc. So here is an inscribed angle. It's an angle inside the circle. And if I tell you that angle 1 in here is 60 degrees, because it's inscribed all the way inside the circle, that means we can assume that this arc is going to be 120 degrees. It's always going to be double the inscribed angle measure. Then we have if two inscribed angles of a circle intercept at the same arc or congruent arcs, then the angles are congruent. So what we have here is one angle right there and another angle over here. And if you notice, they both have the same arc length. Okay, so they all intersect here. So let's say I know that this is 80. Because they have that shared arc, I can assume that the inside measures are each going to be the same. Therefore, each of them are 40. Because remember, the arc is double what the actual inscribed angle is. And because they share this arc measure, they're also going to share that angle measure. Then we have if an inscribed angle intercepts at the diameter or semicircle, then we have a right angle. So this is still going to be an arc, but it happens to be half the circle. Okay, so this is 180 degrees. That would be half the circle. If this happens, then you automatically have a 90-degree angle, inscribed angle. Because remember, 180, half of that would be 90. So it would automatically make it a 90-degree angle there. And the last theorem for this set of notes for the beginning is that if we have a quadrilateral that's inscribed the circle, then the opposite angles will be supplementary. Remember, the word supplementary means it adds up to 180 degrees. So they add up and equal 180. So A and C automatically add up to equal 180. And same thing happens in the other direction. B and D add up to 180 degrees. Okay, so we're going to use all this to solve for our angles and arcs. So find the measure of angle X. Let's do that first. And then find arc X or YX. So first of all, angle X is right here. It's an inscribed angle. And if I follow it along, this is the corresponding arc. So remember, inscribed angles are half the arc. So I'm going to take that 86 and divide by 2. That's going to give me 43 degrees. And this is the measure of angle X. Then if I am solving for arc YX, that's right here. And this arc is going to be double the inscribed angle. So I'm going to take the 52 and I'm going to multiply it by 2. And that's going to give me 104. And that is the measure of arc YX. Okay, so those are my two answers for that first example. Then I'm going to go to number 2. So again, I'm solving for angle C. Angle C is right here. This is going to be half of 94. So to find the measure of angle C, I'm going to do 94 divided by 2, which gives me 47 degrees. And then to find the measure of arc BC, that's right here. And this time I'm going to take 48 and multiply it by 2, which is going to give me 96. And that is my answer for that one. Let's keep going for these examples. In example 3, we have angle S intersecting at this arc, and then I have angle R intersecting at this arc. So they actually have that shared arc, which means that angle R and angle S are congruent. They are equal to each other. So I can set up 12x minus 13, set it equal to 9x plus 2, and start solving for x. Subtract the 9x over 3x minus 13 equal 2. I'm going to add the 13. 3x equals 15, and then divide by 3. Now, this is not your final answer yet because we are solving for angle R. So I'm going to take that 5 and substitute it for the value of angle R. So I have 12 times 5 minus 13 is going to give me 47 degrees as my answer. Okay. Number 4 is very similar. I'm looking for angle I this time, which is right here. And that is the intercepted arc. And it happens to also match that of J. So I'll do the same thing and set them equal to each other. Okay, so I move the 8x over. Then I have 9 equals 2x minus 1. Add the 1 over. 10 equals 2x. And then I divide by 2. Remember, this is not your final answer because you still want to substitute back to angle I and figure out the angle measurement. So I get x equals 5 over here. I didn't write down the answer. Plus 9, so angle I comes out to be 49 degrees. Okay, 2 more examples with these intercepted arcs. For this number 5, I have a special case where my intercepted arc happens to be the semicircle, right? It's going through the center, creating that diameter. And what we said about this is that it creates a 90-degree angle here automatically. So really what I have going on here is a 90-degree angle. This, that's 4, and then 8x minus 4. Now think about how all triangles add up to 180, right? Well, this is already equal to 90, which means that this angle and this angle together would add up to 90 because 90 and 90 would give me that 180 in my triangle. So I'm going to combine like terms. I can combine the x and the 8x in this case. I have 9x. The 4 minus 4 is going to go away. And then I'm going to divide both sides by 9. So x, oh, sorry, this is supposed to be 90. We said that, and then I wrote something else. So this is 90, and then when I divide by 9, I get 10. So that's my x value. Again, because this is already 90, and I know 90 plus these two being 90 will equal 180 for my entire triangle. If you wanted to go ahead and set it all up as x plus 4 plus 8x minus 4 plus 90 equals 180, you can do that as well, okay? I just skipped that step because we already know that 90 and 90 is 180. My last step here is going to be to substitute in for angle B. Angle B in this case is 8x minus 4. X is 10. And so when I do that, angle B comes out to be 76 degrees. So just be careful on which angle you are finding. The last one for inscribed angles, we have angle N, where that's what we're looking for. Now this is a quadrilateral, right? It has 4 sides. And one of the theorems says that the opposite angles are going to be supplementary. That means they add up to 180. So I'm going to take the values of both of these angles and set them equal to 180. Start by combining like terms. That gives me 14x plus 12 equals 180. Subtract the 12 over. That gives me 14x equals to 168. And then divide both sides by 14. X equals 12. And again, go back and substitute to the correct angle. This time we're looking for angle N. And that value is right there. So 3 times 12 plus 12 gives me angle N is 48 degrees. And that is the end of that one. So now we're going to also do section 9.5, which is all about tangents. And the definition of a tangent, it's a line in the plane of a circle that intersects the circle in exactly one point. So a tangent line is going to touch the circle only once, okay? The point of tangency is the point between the tangent line and the circle. And then a common tangent is going to be a one-liner segment that is going to touch 2 circles on one plane. So we're all talking about one plane here. Looking at these 3 pictures, we have no common tangent in the first one. There isn't a line that's touching either of these circles. Okay. So no common tangent on this one. If I were to draw a tangent, for example, in that first circle, there's no way it's also going to just touch the other circle ones. However, if I draw, let me try to do a better job there, a line that barely touches the circle there and there, that's a common tangent because it only touches the circle once. And I can also draw another one in this direction. Okay, so this one happens to have two common tangents. So again, a tangent just touches the circle once. I can't make it go across like the first one. That's not a tangent. And then the last one here already has the tangents drawn in for me. So I have 1, 2, 3, and 4. So this one has 4 common tangents. So again, a tangent is just a line that touches the circle just once. All right, so we have a few more theorems here. In a plane, a line is tangent to a circle if and only if it's perpendicular to the radius drawn to the point of tangency. So this would be my tangent line. This is my radius, and when the tangent and the radius intersect, that's going to create a 90-degree angle. So using this, I would be able to check by using the Pythagorean theorem. And remember, the Pythagorean theorem is a squared plus b squared equals c squared. So this is a formula that will come in handy to solve for the missing sides, like in this example right here. So examples 1 and 2, we are told that this is the radius, KL is the radius. Determine whether LM, so this side, is tangent to circle K. In order for this to happen, this would have to be a 90-degree angle. So here's how I'm going to check to see if this is true. I'm going to do the Pythagorean theorem, a squared plus b squared equals c squared. In this case, my a is going to be 20 and my b is going to be 21. The only one that matters here is going to be the c value. That's always the longest, and it's always across my potential 90-degree angle. In this case, when I enter this in my calculator, I get 841. And when I enter this in my calculator, I also get 841. So yes, LM is tangent to the circle. So is tangent to circle K. Okay, so we're going to do the same process for example 2, see if this creates a 90-degree angle by checking using the Pythagorean theorem. 14 squared plus 16 squared, does that equal 21 squared? This in my calculator is 452, and this in my calculator is 441. These are not equal to each other, so this is not a tangent line, okay? All right, just a few more examples here. In this figure, we have WE is tangent. So this time we don't have to prove it. It's telling us that it is. So I can assume that's a 90-degree angle right there. Now I want to find the value of x. Now let's pay close attention to this picture because x is this side of the triangle, but it is also part of the hypotenuse. So if I were to express the hypotenuse as one expression going from here to here, I would have to call it x plus 16. There's two pieces to that. There's the x and the 16. So I have to make sure that my c value for across that 90-degree angle is x plus 16. So if I were to follow the Pythagorean theorem, a squared plus b squared equals c squared, well, first, my c squared is always across the 90-degree angle, so I have to take the x plus 16 and square it. A and b are just the sides, so this is x squared, and this is 24 squared. And for this one, you're going to have to do double distribution for x plus 16. So this really means multiply x plus 16 times x plus 16 and use double distribution, right? So x times x is x squared plus 16x. 16 times x is another 16x. And 16 times 16 is 256. So I combine my like terms and I get 32x for that one. And 256 here. Oops, that was not an equal to. It's a plus, and then x squared there. So all of that on the right, my c squared, comes out to be x squared plus 32x plus 256. And then I still have x squared plus 24 squared is 576. So I start solving for x. I'm going to subtract the x squared from both sides. And when I do that, it's actually going to cancel from both sides. So then I have 576 equals 32x plus 256. I'm going to subtract 256 from both sides. 32x here, and then I get 320 over here, and divide both sides by 32. X equals 10. So that one was a little bit more work, but it's a good review to practice double distribution. All right. The last theorem we have here for this section is going to be that if two segments from the same exterior point are tangent to a circle, then they are congruent. So remember, a tangent line just touches a circle once. It's here and here. So what this theorem is saying is that if they intersect from one common angle, they are going to be equal to each other. Therefore, for this very last example, if I have AC and BC are tangents, and they both come together at the same exterior angle, the same exterior point, then I can actually set them equal to each other. So 3x plus 2 equals 4x minus 3, and then you just solve for x. I'm going to subtract the 3x first. Then I have 2 equals 1x minus 3, and then I add the 3 over. So x equals 5 as my final answer here. And we are done. So that's really all you need to know about tangents and inscribed angles. That was the 9.4 part of this. Make sure you're asking us questions if any of this does not make any sense. Thanks for watching.